Let's solve this problem using the Intermediate Value Theorem to prove that the equation x cubed plus x squared minus 2x minus 1 equals 0 has at least one solution in the interval -1 to 1. Let's approach this step by step. First, let's define our function f of x equals x cubed plus x squared minus 2x minus 1. Since this is a polynomial function, we know it's continuous everywhere. Let's visualize this function. Here's our coordinate system, and here's the graph of our function. Notice how it's smooth and continuous. Now, let's evaluate f of -1. When we substitute x equals -1, we get -1 cubed plus -1 squared, minus 2 times -1. Minus 1. This simplifies to -1 plus 1 plus 2 minus 1, which equals 1. So f of -1 equals 1. Similarly, let's evaluate f of 1. When x equals 1, we get 1 cubed plus 1 squared minus 2 times 1 minus 1. This simplifies to 1 plus 1 minus 2 minus 1, which equals -1. So f of 1 equals -1. Now, here's where the intermediate value theorem comes in. Since f is continuous on the interval -1 to 1, and f of -1 equals 1, which is positive, while f of 1 equals -1, which is negative by the intermediate value theorem, there must be some value c in the interval -1 to 1, where f of c equals 0. In conclusion, we've proven that there must be at least one solution to our equation in the interval -1 to 1. We did this by showing that our continuous function changes from positive to negative over this interval, which means it must cross the x-axis at least once.